What's poppin', dogs? Mr. Allen here with some graphing of wonderful, fantastic quadratic functions. Here we've got one in standard or general form, depending on what your teacher uses there. I'm a standard form kind of guy, but some people do refer to it as general form. What else? All right, we want to graph this thing, right? We're going to use at least 3 key points, maybe 5, and we're also going to find some of this key information here, all right? Now, on a test, they might not ask for all this information, but I am going to show how to get all this information in this particular form here, because I'm just dope like that. All right, so let's go for it. Is it opening up or is it opening down? This one, it's positive for our lead coefficient, so we are opening up like a cup. That's awesome. Axis of symmetry. Okay. For that one, I need a fun little formula there. Actually, you know what? Before I do that, what's the easiest piece of information to get from standard, aka general form here? It's my y-intercept. If I plug 0 into this thing, right? If I plug 0 in here, 0. 0 here, 0. I'm just left with 5. So that is our easiest piece of information, along with which way it opens, to get from standard or general form, all right? Back to the axis of symmetry. I need to use this fancy little formula here, opposite of b over 2a. So when I do that, opposite of b is -6 over 2 times 1. That's going to give me -6 divided by 2. So I'm going to have x equals -3. That's my axis of symmetry right there. I'm not really sure exactly where the graph's going to go. I didn't want to impede too much, right? Vertex time. How in the heck do I get my vertex? Well, I just did the axis of symmetry, and the axis of symmetry, which I can plot right now. You know, I'm going to use a fancy ruler again here. Whoop. Axis of symmetry, x equals -3. Lovely. Arrows. Awesome. My vertex is going to be somewhere on that axis of symmetry. So I can use that x-coordinate, which is -3, and I can plug it in to get my y-coordinate. All right? So that's pretty awesome there. That's a nice little fancy thing to do. And guess what? If I have an x-coordinate in any function, if that x-coordinate exists on that graph, I can plug it in and I will get the y-coordinate. That goes with it. Not just for my vertex, not just for my x-intercepts, not just for the y-intercept like we did here where I plugged in 0 and I got 5. Anything I want. Generally speaking, though, we're doing our key points, our vertex, our y-intercept, things like that. Okay? So I'm going to do this work off to the side because I know this graph is going to be somewhere over here. It's positive, opening up. I'm going to work the vertex over here. So I've got f of -3, right? We're plugging in -3 here. That's what this states here. It says f of -3. That means I'm going to plug -3 in for all of my x's and evaluate it. But it's a lot easier to say that's all I'm going to do by writing this notation here. That's function notation. So I got -3 squared plus 6 times -3 plus 5. Hopefully I didn't run out of room. Let me check my watch. We're Gucci. Okay. Next up, we got -3 squared is 9. 6 times -3, that's -18 plus 5. Now I've got what? -9 plus 5. It's going to be -4. Beautiful. So I got -4 right there. All right. So I got my vertex. Let's go ahead and plot that thing. -3, -1, 2, 3, 4. Whoop. There it is. So it's going to look something like this, right? So next thing here, let's see. We got our y-intercept. I can actually plot that 0, 5. 1, 2, 3, 4, 5. Nice. And I am 3 away from my axis of symmetry, aren't I? Would it be logical that I could just say, okay, I can go 3 this way, I can go 3 over this way? I know I'm getting into like some of the question there, but that would be symmetrical, right? The whole point of the axis of symmetry. And now I have enough to connect these dots, but I am going to do a little bit more here. So we want our x-intercepts. There's a way to get these x-intercepts. Again, they might not require it of you right now, but we should know at this point how to factor. So I can take this, let's see here, this function and set it equal to 0. I'll do it over here as well. 0 equals x squared plus 6x plus 5. Well, what multiplies to 5 and adds to 6? That'd be +5 and +1. 5 times 1 is 5. 5 plus 1 is 6. And if I set these equal to 0, I just put this in factored form, right? We were given factored form in other examples. Here I'm putting it in factored form myself so that I can solve for my x-intercepts. Ain't that a fun little thing to do? So I've got -5, 0, and I've got -1, 0. Let's plot those points. -1, 0 is here. That's 3, 4, 5. Oh, man, look at that's looking nice right there. And just for fun here, I'm going to show you guys there's actually another point here and another one here. I could plug -2 in here and get the points, but I'm just going point frenzy here. You don't need all of these points, but hey, the more points, the more accurate your graph is going to be. Generally speaking, though, they're only going to require 3, maybe 5 points when you're graphing a quadratic. Since we had to get the x-intercepts and they fit nicely on the graph, figure why the heck not? Y-intercept was the key one there because we could reflect that over and get another point for free, and we already had our vertex. So there we go, guys. Graphed in standard form. This is beautiful, right? Mathematical poetry. All right. If you guys need the other ones, make sure you check out the other couple videos there, factored form as well as vertex form, right? Because there are different strategies that we use for each form. So knowing how to work with each 3, it's going to be super helpful to you and save you some time. Otherwise, you're going to be going through all these crazy stuff. It's going to get confusing. All right. So watch all 3, all right? Get all 3 in your repertoire. And that's it. Have a great day.